The wheel you see here is a version of Bhaskara's wheel, or otherwise called an overbalanced wheel. Designed around 1159 AD, he reasoned that as the wheel spun, the balls would roll to the bottom of each reservoir, leaving one side of the wheel perpetually heavier than the other. The imbalance would keep the wheel turning forever. Bhaskara's drawing was one of the earliest designs for a perpetual motion machine, a device that could do work indefinitely without any external energy source. These devices have captured many inventors' imaginations because they could transform a relationship with energy. For example, if we could build a perpetual motion machine that included humans as a part of its perfectly efficient system, it could sustain life indefinitely. There's just one problem: they don't work. Ideas for perpetual motion machines all violate one or more fundamental laws of thermodynamics, the branch of physics that describes the relationship between different forms of energy. The first law of thermodynamics says that energy can't be created or destroyed. You can't get out more energy than you put in. That rules out a useful perpetual motion machine right away, because a machine could only ever produce as much energy as it consumed. There wouldn't be any left over to power a car or charge a phone. But what if you just wanted the machine to keep itself moving? Inventors have proposed plenty of ideas. Several of these have been variations on Bhaskara's overbalanced wheel with flowing liquids or weights on arms. None of them work. The moving parts that make one side of the wheel heavier shift the center of mass downwards. Therefore, with a low center of mass, the wheel just swings back and forth like a pendulum, then stops. What about a different approach? In the 17th century, Robert Boyle came up with an idea of a self-watering pot. He theorized that capillary action, the attraction between liquids and surfaces that pulls water through thin tubes, would keep the water cycling around the tube. But if the capillary action is strong enough to overcome gravity and draw the water up, it would also prevent it from falling back into the bowl. For all these machines to keep moving, they'd have to create some extra energy to nudge the system past its stopping point, breaking the first law of thermodynamics. There are ones that seem to keep going, but in reality they invariably turn to be drawing energy from some external source. Even if engineers could somehow design a machine that didn't violate the first law of thermodynamics, it still wouldn't work in the real world because of the second law. The second law of thermodynamics tells us that energy tends to spread out through processes like friction. Any real machine would have moving parts or interactions with air or liquid molecules. That would generate tiny amounts of friction and heat, even in vacuum. That heat is energy escaping, and it would keep leaching out, reducing the energy available to move the system itself, until the machine inevitably stopped. So far, these two laws of thermodynamics have stopped every idea for perpetual motion and the dreams of perpetually efficient energy generations they imply. Yet it's hard to conclusively say that we'll never discover a perpetual motion machine because there's still so much we don't understand about the universe. Perhaps we'll find new exotic forms of matter that will force us to revisit the laws of thermodynamics. Or there's perpetual motion on tiny quantum scales. For now, we can reasonably be sure that we'll never stop looking. For now, the only thing that seems truly perpetual is our search. Thank you.